like लोहार का भट्टी होती थी, घुमा कर उसके अंदर गर्म करके then you used to quench it, and that was also part of heat treatment, and that was a crude furnace that you would be seeing earlier. So now as the times are changing, things are changing, so we need more good looking equipment in your factories and all that, and so that, but they should also be giving you the parameters and the stringent parameters which are called for today, because at that point of time a lot of people are not aware of what heat treatment is, what are the various parameters. Like as the things are going on, your parameters are getting more and more stringent, your customers are asking for more stringent regulation of temperatures and all that, so the equipments are changing. Over the years and centuries, continuous endeavor has been done to change the things, and as we can see, the various developments have been in these areas, that is of refractory materials, insulating materials, the combustion systems, the heating systems, the control systems as such, and the materials which are used in your equipments as charge carriers and all those things. So what are the various classifications of the furnaces? What we have is, they're classified as the energy source. That is one, either you are using furnace oil, or you are using LDO, or you are using any other source of heat. When you come to gas, it is either you are using LPG, you are using natural gas, or you are using other forms of heating systems. When you come to electrical, it will come to resistance, or you are coming to induction, or you are coming to dielectric heating, or you have the arc heating. So these are the various classifications as far as the energy source goes. After this, you come to the duty cycle. So whether your furnace is a batch type of a furnace or a continuous furnace. So you would be having a muffle furnace, or a pit furnace, or a bogie furnace, or a salt bath furnace. These would all come under the duty cycle of your operations. And if it is a continuous furnace, you will be looking at a conveyor furnace, or a pusher furnace, or a walking beam furnace, or a rotary hearth furnace, or a shaker hearth furnace, or a tunnel furnace, a pull-through furnace, or a roller hearth furnace. So these will be the various parameters we'll be looking into when you are coming into your process. Involves in continuous sort of an operation, where the equipment, the material goes in on one side and comes out on the other side. So you need some sort of a system to take it through. So these are the various processes which are available either as conveyors or pushers or pull-throughs, which are available to you today for getting your job done. Then we come to the type of heat transfer. It can be conductive, convective, or radiative. So these are the three forms of basic heat treatment heating cycles. And the fourth one that we are calling today is the plasma, which is the latest development, and is the fourth state of matter, that is plasma. And it is now being rigorously used in various subjects, like for nitriding and for carburizing, you are using plasma heated furnaces. Then you come to the atmospheres. What generally you are doing is heating an equipment in air, but certain equipments would require that you don't have scaling on your components, so you have to use an inert gas atmosphere. So there will be either argon or nitrogen. You will be purging it in your chambers. So there you need another muffle inside your furnace so that you can purge it with the gases. Then you have got a reducing atmosphere or an carburizing atmosphere, a nitriding atmosphere, as you had just heard about the various processes. So for each of those processes, you will be having a different type of an equipment, and ultimately now what you are looking at is a vacuum furnace, which is a bit more expensive, but it sorts out a lot of heat treatment processes, and it gives you more accuracy as far as your heat treatment is concerned. Then you come to the heat treatment. What are the end uses? So the end using would be either you are using your equipment for drying, or you are using it for baking, or you are using it for calcining, or you are using it for stress relieving, or you are using it for annealing, normalizing, hardening, or for case hardening. And then you come to the melting furnaces. That could be done either for crucible melting, arc melting, rotary furnaces, or the open hearth furnaces. And today what you're looking at is also induction heating, melting and heat treatment furnaces. Now we come to what is, this will come later. I'll talk to you a bit about what are the various developments in the refractories which have taken place. We all know that the workhorses for the heat treatment industry had been the IS-8 and IS-6. I think all of you must be aware of, and your companies will be procuring these materials for your furnace base of the furnace. That is the abrasive resistant and where there is shock. So you normally use this IS-8 and IS-6, which was normally traditionally called the workhorse for all the equipments for furnaces. Now sillimanite has been used basically where there is high strength requirements and the thermal shock resistance are required. Then you use at elevated temperatures, you don't use IS-6 and IS-8, you go for the sillimanite type of bridge. Now the electrical furnaces, if you look into them, have led to the development of high alumina refractories. And why do you need high alumina refractories is that the elements that you put in the refractory are such that the refractory should not have any iron content in them. So the moment there is an iron content, it reacts with your element and it fuses. So your refractory should have zero or near zero iron content. Fe2O3 should not be there in your element holding refractories. That is the first thing. So this was what was developed as far as the electrical resistance furnaces went. Then a need came in for higher temperatures. Like we were talking for heat treatment, if you've seen 900 degrees and 1000 degrees, but now what the heat treatments and the new alloy structures and the new metals, you're looking at temperatures of 1100 plus 1200 stainless steels, and some materials even require temperatures beyond 1300, 1350, 1400. So the generally available wires and equipment which was there for heating was not available. Like Kanthal A1, as you would all be knowing, I don't know, most of you must be aware, Kanthal is a brand name, wires made by a company in Sweden. Now they were having a monopoly over these wire manufacturing. But now of late, China, Japan, all of them have started, and even in India there are few plants who have started manufacturing these wires. The basic content of this wire is 80% of iron, and the balance is all a conglomeration of a lot of other materials which nobody knows what is the final end product. So if you go to analyze and you try to manufacture it yourself, it is not feasible. They tried to do it at DMRL in Hyderabad. They had made the ingot for Kanthal, but then they could not do the future processing of the same, and they were trying to give out people the billets for Kanthal manufacturing. I think that is what people are using today to manufacture the Kanthal wire. So the only thing is that it has more of iron content, but the price is like gold. So that is the only difference, because it's a monopoly type of an item. So nobody can touch that item. So that for that reason we needed basically refractories which were without iron content. The alumina contents for higher temperatures, the alumina content has gone up to as far as 99% of alumina. And these refractories can be used up to temperatures of 1700 degrees or 1850 degrees centigrade, and have a very high thermal shock resistance and also a very high abrasive resistance. They also show excellent stability in the highly reducing atmospheres. So such refractories find application in hearths for billet heating furnaces, for combustion chambers where there is an oil fired furnace, lining in high temperature furnaces, hearths of alumina remelt furnaces, ladle line furnaces, and for high manganese steel, etc. These are the various requirements where you use these refractories. Then we came to the next stage of refractories, that was silicon carbide. So silicon carbide refractories were developed basically for their excellent shock resistance, thermal conduction and thermal strength properties at elevated temperatures. So this was the next development as far as the refractories was concerned, and these have a resistance of temperature up to 1800 degrees centigrade. So they can be used as hearth plates, they can be used as charge carriers or charge supports, they can be used for rollers in furnaces, and also for in the roller hearth furnaces you can use them as rollers also. So another recent development is applying a high emissivity coating. I think that will be covered later in the evening also, as a coating which you use in your refractory line furnaces. So if you have a refractory line furnaces, after a certain usage there are certain vents which come up in the lining. So your heat loss starts from your end surfaces, from your lining. So this is a coating which is available. You just coat the inner surface of your lining of your furnace so that it blocks all the outlets of heat and hence improves again your emissivity in the furnace. So your heating rate comes up faster and you save the energy that you are losing from your furnaces which have got old, instead of relining the whole furnace. So this is a lecture which will be coming up later on, but a few statistics I can give you is why do you need that is basically because you get a rapid heat up time, that is reduction in heating time if you use these emissivity coatings is up to 30%. They have been reported by a lot of our customers. The increased heat transfer at steady rate, saving of fuel is up to 17% has been reported for these emissivity linings.